can you write this down? You are going to be making notes for me today, and what you need to write down is this formula for me. And the most important thing when you're writing down this formula is the following. The little letters are always the sides, and the big letters are always the angles. Just make sure you differentiate between the little letters, which are sides, and the big letters, which are angles. And you may want to, but perhaps you just want to listen, copy down, for example, anything else on the screen, because I'm going to be talking about that in a second. I'm going to give you 2 minutes to copy down as many things as you can from the screen, okay? Right, so we're going to talk about now the different things to do with this. Can you hear me all right still? We're going to talk about why we use sine or cosine, and this is quite a complex concept, and I probably learnt this when I was in M5, and I probably didn't quite understand it, so I want you to make sure you understand why. So we need to consider things in terms of pairs. So on the right hand side, I'm colouring in things with a circle. So you're often given a triangle, and it's your job to label it. So what I would do, for example, for this question at the bottom, is I'd get my pen. I'm going to label one of the angles as lowercase b. This is already labelled for me, so this is going to be capital B. I'd label one of the angles as lowercase a and then capital A. And then we know this problem is to do with the A's and B's. Although we've got 3 things equal to each other, it means we only actually ever use 2 of the 3 things in the equation.
What we're going to do now is have a look at the image on the bottom right and see which out of lowercase a and b and uppercase A and B do we actually have given to us.
Well done. So we're going to replace the lowercase a, the uppercase A, the uppercase B to find B, and that's the kind of thing we're going to be doing in these questions. Right, so another really interesting thing about this is it doesn't matter whether you put the angles on the top or you put the lowercase letters on the top. Now there's different reasons why you want to do this, and you might want to make a note of this. And the reason why you would use that one if you want to find a missing side is because you want to generate the missing side to be on top of the fraction, which it is, and then it's easier to solve. Can anyone guess then what we'd use the second one for? Fantastic, missing angle. So I'm going to give you 1 minute to copy that down, make some notes. You might want to copy the second equation down and ask me any questions. I'll still be here. Alexa, start 1 minute timer.
1 minute, starting now.
Right, so for the key thing we need to do for this is we need to focus on the following. So these are the kind of things that will allow you to use the sine rule. Now for some people this gets a little bit confusing, so this is an optional thing to copy down. You need an ASA triangle, an AAS triangle, or an SSA triangle to use the sine rule, and I need to explain what that means. It means you have got an angle, then a side, then an angle, then an angle, then a side, or a side, then angle. So we're going to say, for example, which out of these 2 triangles is an SSA? Can I please ask Libby? Is Libby there still? Well done. So the reason why is because this is a side, and this is an angle. That's the order it's in. Side, side, angle. Whereas this one is going to be, which one of these 2 is the first one? AAS is an angle, then a side. So if this makes sense to you, you can write this down. Effectively, what you're looking for is something that is matching. And what I mean by something matching is that you have an angle and then you have the side opposite it. So you could have the following. I'm going to get a little circle to show you what exactly I mean. I'm just looking for, I'm going to insert a circle and I'm going to get rid of the fill. So for example, for the one on the left, we have a matching side with a matching angle.
What I mean by matching is the fact that the angle and the side opposite are both given to you in the question. So this is what I mean by a matching pair. It's also quite clear that the triangle on the right also has a matching pair because you have the angle at C or the angle at BCA matching with the opposite side, which is 8.1 centimetres. So we've got another matching pair. Now, to use the sine rule, you have to have two matching pairs in the question. So you have to have a pair that is given to you and a pair where you have one part of the pair and one part that you need. So for the red triangle, we have 37 degrees and then we have the side that we need. Now looking at the bottom, you can see that we cannot use the sine rule for this one. And the reason is because we have no matching pair. The 112 degrees matches with the x, but they are not both given to you in the question. You need one pair where at least the side and the angle are both given to you in the question. Another way of thinking of this, rather than in terms of matching pairs, is whether a triangle is ASA, AAS, SSA. And what we mean by that is if we have a look at the triangles. So if we have something which is AAS, this is going to be a angle, then a side. So for this particular one, we can see on the screen 10 centimetres is the side, then we've got an angle which is 40 centimetres, and then we've got another angle which is on the right hand side. So this would be a side angle or AAS. So we can indeed use the sine rule. Now let's have a look how to solve this. First thing we ask ourselves,
is there a matching pair? Yeah. I'm going to say sine of A over little a equals sine of B over little b, and then I'm going to label appropriately. I'm going to say I'm going to call this little a big A and little a. This is going to be big B and little b. Can somebody remind me why I've labelled the angles with these kind of letters?
So the reason why we've labelled them like this is because angles are always labelled with capital letters and sides with lowercase letters. The next step is to replace all the ticked numbers or letters into the equation. So we're substituting the letters for the numbers. So let's replace capital A, and we're going to leave it as it is. We're going to replace it with theta. Lowercase a is going to be replaced with 7.1, B is going to be replaced with 65 degrees, and lowercase b is going to be replaced with 10 centimetres. This is simply substitution. Now I'd like you to pause the video and have a go at solving this. You're going to have to rearrange to make theta the subject of the formula. So the way we're going to solve this is first of all have a think about how we would solve the blue equation. So if we wanted to find out what x was, we need to rearrange the equation. The first thing I focus on is the denominators of the fraction. Now we do not want the 2 on the left hand side because that is a denominator of something which is a variable or an unknown. So we're going to take the 2 to the other side by multiplying both sides by 2. That changes the 5 to a 10, and then our overall fraction simplifies to 2/3. We're going to use a very similar method for this one, and this will always be the same for the sine rule. We would like theta on its own, so the first thing we need to eliminate is to eliminate the 7.1. Now, to get rid of the 7.1, we are going to have to do the inverse of divide by 7.1. And the inverse of divide by 7.1 is going to be times by 7.1. And the reason why we're doing this is because we can see everything is on the correct side. Theta is on the left-hand side, and we want to solve for theta. We've got sine 65 and 10 on the right-hand side of the equation, which are numbers which are on a separate side to theta. So the only thing on the wrong side is the 7.1. So let's go and start solving this equation. So for ease of this question, we're going to type or write our first step, which is timesing both sides by 7.1. Once we get that, we are going to get sine theta on its own. So after this step, we only need to do one more step to get theta on its own. I'd like you to pause the video in a moment and have a think about how are you going to get theta on its own. Welcome back. Hopefully you realise we need to eliminate the sine. Now to eliminate the sine, we need to find the inverse of both sides of the equation. So the inverse of sine is clearly going to be sine to the power of -1, and you find this on your calculator by pressing Shift Sine. This, sometimes on a Spanish calculator, can be referred to as arc sine, so either sine to the power of -1 or arc sine. As expected, theta is going to be the arc sine of 7.1 times sine of 65 divided by 10, and that's going to give us approximately 40 degrees to the nearest whole degree. So that should be nice and simple. What I'd like you to have a go at is some questions coming up on the screen. So I want you to have a think about which of these triangles we can apply the sine rule to. Remember, if we can circle one matching pair, we can find the missing information to see whether we can apply the sine rule.
Yes.
So for the first one, indeed, we can circle the 92 and 41, which means we can find angle B.
A.
For example, if we were
Yes, so
told
we would
to
be able
find
to
the
apply the
angle in
sine
the
rule.
bottom
All I
right
want
of the
to know
triangle,
is it
we
yes
could
or
still
no,
use
can we
sine
apply
rule
the rule?
because
Yes,
we could
we
first
can,
find
because
angle
the
B
matching pair-
and then
the
add together
matching pair
92
is
and
here.
B
Okay, I'm
to
next going
find
to
the
ask
missing
Jill.
angle.
Is
Again,
there
with
a
the second
matching pair for
example,
the second
we
one?
can find B, again using the sine rule, because we have a matching pair. Our matching pair to begin with this time
Can't hear Jill,
is
Jill's trying to talk.
105.1. However,
Yes, there is.
looking at the third
Yes, there is.
example
Well done, Stella.
along the
This is a
screen,
matching pair, so we can't apply
there are
the
no
sine rule.
matching
This
pairs
one here,
whatsoever.
is there a matching pair, Clara?
The 8 and the 16
No.
are a pair,
No. So
and they
this
are
is when we
matching,
apply the
however they're
cosine
not
rule,
given
which
at
we'll
the
learn
beginning
about
of the
next lesson.
question. We do not
This
have
one
enough
here at the
information
bottom,
because no
is
angles
there
are
a
given in this
matching pair
problem.
that's given to us?
This triangle is a side-side-side
No,
triangle.
because we don't know what
This
X
one,
is.
again,
Vita,
we
is
do
there
not
a matching
have
pair
a
for
matching
this one?
pair given to us at the beginning of the question.
Yeah, there is a matching pair. We've
Example
got these
number
two.
5,
We can use the sine
this
rule.
time we do,
Is
so we
there a
can
matching
apply the
pair for
sine
the one
rule.
at the bottom?
And the last two
No,
examples,
Andres, what
this one,
topic is this one at the
you
bottom?
can see this is a right angle
Pythagoras.
triangle. So with a right
Pythagoras,
angle
well done.
triangle,
So
we
this
can
is
just
no. And then the
apply
final one, is there a
Pythagoras.
matching pair for
And last
this
but
one?
not least, again,
No.
we have no
No, so this one
angle
would be
given to
cosine.
us,
Well
so we
done.
cannot
Okay.
apply the
I
sine rule.
need to, before you leave, take a
So for the
screenshot
ones
of
we
everyone
cannot
who's
apply the
here.
sine rule, we need to
So
apply
what
the
I'm going to do is
cosine
I'm going to
rule.
go back